Let's go ahead and try a series circuit example now that we've learned what series circuits are and kind of how they work. And let's give this series circuit 3 resistors. And let's say one resistor is 220 ohms. Let's give the second resistor 470 ohms. And just to get a little crazy, let's say this last one is 1.2 kilo ohms. And then let's go ahead and say that it has a power source of 12 volts. There's a lot of things we have to solve to figure out the series circuit. And the first one, at least the first one obviously to me, is the resistance total. And as we've learned in our last few videos, the resistance total is just adding up all of our resistors. Since there are only 3, let's just add up the 3. And we'll go ahead and name these. It doesn't really matter what you name them as long as you're consistent, but I'm going to name them left to right, R1, R2, and R3. And then real quick, a note about R3. If you notice that kilo ohms, that's not a consistent unit. So we need to convert that. 1 kilo ohm is 1,000 ohms. So let's make this 1,200 ohms so that we have a consistent unit to work with. And we can just plug these into our handy-dandy calculator. We'll add up our 3 resistors, R1, which is 220, plus 470, R2, plus 1,200 ohms, which is R3. And what do we get when we hit enter? We get 1,890 ohms for our total resistance. Too easy, too obvious. The next thing we need to solve is, of course, the current. And the current is the same formula as usual. It's just voltage divided by resistance. And you might ask yourself, well, which resistance are we going to use? There are 3 listed, and we just figured out a 4th one. Well, you're going to use based on what you have. So we don't know the voltage drop across resistor 1. Therefore, we don't know the voltage for resistor 1. Likewise, we don't know the voltage for resistor 2 or the voltage drop across resistor 3 yet. That's actually 3 of the things we need to solve for still. But we do know the total voltage drop. Therefore, we will use the matching resistance total to go with the voltage total. And of course, we know both of these numbers. That's kind of the point here. And what do we put on top is 12 volts. And on bottom, we'll put 1,890 ohms. And we'll plug these into our handy-dandy calculator. So we'll say 12 divided by 1,890. And what do we get? We get 0.006349. So let's go ahead and just round that to 0.0063 amps. Or we could rewrite it as we want, or if we want to, into 6.3 milliamps. And all we did was just take that decimal place and move it 3 places to get it right here. And both of these are correct, and which one you would use is depending on what the question is asking for. Unless you're using it in a math problem, in which case you would use just the regular units. For example, if we wanted to find the voltage drop across resistor 1. So we'll call that voltage 1 for, of course, voltage across, or the voltage drop across resistor 1. And the formula for voltage is the same. It's current times resistance. But if it's voltage drop across resistor 1, we'll use resistor 1. And since there's only one current, we'll just go ahead and use that one current. So that's 0.0063 multiplied by our resistance, which resistor 1 we just said was 220 ohms. And then we'll just plug this into our handy-dandy calculator. We get 0.0063 times 220 ohms. And what do we get? We get 1.386. Let's just go ahead and round that to 1.4 volts. What about voltage drop 2? So what is the voltage drop across resistor 2? Well, it's going to be current times resistor 2. And of course, current is consistent. It hasn't changed. I cannot stress that enough. So it's 0.0063 multiplied by resistor 2, which is 470 ohms. We type that into our handy-dandy calculator, and what do we get? We get 2.961. Let's go ahead and just round that up to 3.0 volts. And of course, we'll do the exact same thing for the voltage drop across resistor 3, or voltage 3. It's current times resistance 3. We'll just type that into our calculator, 0.0063 times 1200. And what do we get? we get 7.56. Let's just call that 7.6 volts. And of course, thinking about this makes sense. As the electrons travel, they hit resistor 3, and because it's the biggest resistor, it drops 7.6 volts here. Then when it goes across resistor 2, it drops another 3 volts because it's bigger than resistor 1, but not quite as big as resistor 3. And then the smallest voltage drop is, of course, across resistor 1 because it's the smallest resistor.